instruction. We can use this instruction with A. Every instruction can use with A. So if you use this instruction with A, this is supported by the system. Data transfer external RAM. Move X is a new instruction. Move X. Transfer the data external RAM. So this if you want to transfer data from or to external RAM, we use the commands move X. We use the instruction move X. Transfer data by DPTR or by R register or by R register. R1 R0 R register R1 R0. Data transfer of program memory. Is move C. Data for program memory. This move X is for external RAM. This is for ROM. This is for ROM. ROM. Reading instruction of program memory. Indexed addressing model. Designed for reading lookup table in program memory. Data exchange instruction. Data exchange. XCH. Exchange. Data exchange. And just exchange the data between A and the Rn or A direct or this condition. Data exchange. You can see. Okay.
Laoshi, it's data exchange. So we are supposed to be exchanging two different data, right? But this is XCH opcode, and then the operand, destination, and source. Which data are we exchanging?
This exchange can change the lower 4 bits, of two operand, which means we can change the data, the lower 4 bits, and the lower 4 bits of A with the lower 4 bits. It is this address. Just change between the two operand for the lower 4 bits. This SWAT can exchange the A, for the lower 4 bits and the higher 4 bits, higher 4 bits. This for the lower 4 bits. This is for lower 4 bits and the higher 4 bits. This is for the this source destination source and destination just exchange the date in the two register in the two register or in the two address in the two address.
老师 can you give us a real life example like using this data exchange?
You want to see some example?
Yeah, real life example, 老师 we can't imagine.
We can see here. This is a move. Move. We can use make the 20H to the R0 R0. If we change this to move X C H A early to 0 H to 0 H. We can change the value in A exchange A and to 0 H we can to this one yeah, exchange the value in the A and 20H this is XCH XCH. If we use XCHD SCHD just lower just lower lower just like here the lower 4 bit is exchanged with R0 with R0 A. This is A other 8 R0 is this this if we change this 3F 75 we can change to 75 7F 75 7F original this A is 3F 3F 8R0 is 75H if we use command use the instruction exchange CHD this lower 4 bits lower 4 bits and these lower 4 bits they are exchanged so you can get the 3 5H and 7FH 7FH. This is XCHD XCHD. If you use this instruction SWAPA just we can exchange the higher 4 bits and the lower 4 bits 35 to 53H 53H。
老师
Yeah.
Can you say that it is used in which controller, this data exchange in daily life, in which controller it is used?
Which is controlled?
Yeah.
You can see it again.
Now she's asking which microcontroller can you use these instructions for? 8051, like those, like which kind of microcontrollers can you use these instructions for?
Which what?
Yeah, I think we can use this example in 8051, right, Laoshi?
Yeah.
Laoshi, is it only 8051 or there are other microcontrollers? That's what he's asking.
Oh, I know. You mean that you can use this instruction to other microcontroller?
Yeah.
I didn't tell you. Our class we use 51 as the microcontroller as the example. So we name some instruction for the 8051. If the microcontroller is compatible with the 8051, we can use this instruction. If your microcontroller is not or incompatible to the microcontroller 8051, you cannot use this instruction. Okay.
So we will have to learn the instruction of the other microcontrollers that are not compatible with 8051. If we get it, we have to learn the assembly language for that one before we can code it.
Yeah, there's many different instructions for different microcontroller. But if your controller is compatible to the 8051, you can use this instruction. But if your microcontroller is incompatible to the 8051, you cannot use this instruction. You need to find the menu for your
controller,
microcontroller.
So, Laoshi, do you have any? Okay. Yeah, I'm asking, do you have any microcontroller to show us now or even next class? Laoshi?
Sorry.
Yeah, I'm asking, do you have any controller like 8051 to show us today or in next class? Is it possible?
Any other microcontroller are compatible to the 8051?
Yeah, any of them.
Any of them are. Any of them is many microcontroller just like STC STC microcontroller 80 80 line 80 line.
Okay.
Laoshi, he's asking, do you have a microcontroller in your house, or you can show it to us in the next class?
You want to see some microcontroller?
Yeah. Exactly. You are asking to see a microcontroller.
Microcontroller just cheap. Just I already show you. I give you the picture. Okay.
But only one microcontroller can't work, as I know. So you need to set up a whole team to work together.
Okay.
I saw some 8051 last year, but I don't know what kind of controller is that one now.
Yeah.
Is there any like, for example, like you see there's Arduino you can buy online. If I want to buy a controller that is compatible with 8051 microcontroller.
Arduino is not compatible with
I know.
8051.
I know, but if I want to get one that is compatible, which ones can I buy? For example, like example of controllers I can buy that are compatible with 8051.
You need to know. You want to buy some microcontroller.
Yeah.
Okay, wait a minute. Oh, as you can see, this is first generation for the 8051 8051. Now you cannot buy this first generation. This is a second generation. Second generation. 8 mil 8 mil 89 C51 89 51 or 89 C52 52. I suggest if you want to buy some microcontroller, you can buy this type or this type.
Okay.
This is another compatible microcontroller for the 1851 8051 STC STC 89 STC 89. This is a third generation for the 8051 8051. But the third 8051 is there is more instruction for the second generation. So I suggest that you don't buy the third generation. You just buy the second generation from for your study for your study. Just buy this.
Laoshi, which one is more powerful, the second generation or the third generation?
Which one is more powerful?
Yeah.
Which one is more powerful? Maybe the second, the third generation. The third generation is more powerful. But when you first begin on the 8051, I suggest that you buy the second generation.
Okay, Laoshi.
Product. Second generation.
Okay, Laoshi.
Yeah, you buy the second generation.
Laoshi,
80 mil 8050 89 C51 are almost the same with the 8051 almost the same. So for our study, we use 80C51, 8 mil, 9C51.
Okay, 老师。
Okay.
老师，
What?
it's okay, it's fine, it's fine.
Okay.
老师, can you tell us a price range of how much the 869C51 will cost?
How much?
Yeah.
How much? Maybe maybe $1. It's cheap.
老师, in RMBs, in yuan.
US dollar.
In yuan,
8
老师,
yuan,
how
8
much
yuan.
in yuan?
Yuan, maybe 10 yuan RMB.
But 老师, if we buy that small one, we can't use it alone, can we?
Yeah, you cannot use it alone. You need to buy some board, some device for you for the use the chip. Your chip.
Yeah, 老师, that's what I'm asking. Which device board should we buy?
In China there is many board we can buy, but I don't know in your country. I don't know if you can access the
China,
in China we can buy it online.
Yes, some of us are in China, so some of us can buy, and some are not.
You can buy some board on Taobao.
Yes, largely which board?
Which board? I don't know actually which one is better for any others, but I suggest you don't buy any board. You just use the software to simulation your microcontroller. Last time I told you the software. I don't know if you remember this software. It's software. We can use software to simulate the microcontroller. You needn't to buy any board. You needn't to buy board. Just use this software to simulate your. I give you an example.
Okay, example.
Okay.
Okay, Lash.
I give you an example. Can you see that?
Yes, Lash. Okay.
This is a software. Protos 8 Professional. Professional.
Lash, it's for free?
Oh no, not free.
Huh?
You need to buy it.
Okay, no problem, Lash. We will
you
find the free one.
can this we can simulate this example output parts for this we can simulate the program. We can I tell you the program. This is a program for this microcontroller systems. This is a microcontroller just output parts. Just output parts. This is a assembly language code. Assembly language code. This is a scope.
老师 老师 is there a practical part of this course?
Part of what?
Is there a practical part in this course?
Practice part.
Yeah.
老师 practical class.
You need to find some device in this software. Yeah.
Okay.
This is for the device.
No,
Analog IC.
I'm asking if we will have a practical session in this class in the future.
You need to know if we arrange some class for this software.
Yeah.
Okay. After we learn something fundamental for the microcontroller, we will tell you some example. We use this example with this software.
Okay, okay. We will look for the free version.
That would be interesting for you to understand the microcontroller.
Okay.
But now we don't have any fundamental about the microcontroller. And if you know something about the microcontroller, maybe we can give you some example for how to simulate the microcontroller in this software.
Okay.
Anyone know something about? If you need, we continue introduce some fundamental about the microcontroller.
Yes.
Yes.
Yeah.
Okay.
Let's continue.
Okay. Maybe after several times, we can introduce how to use this software.
Okay. Lars. Thank you.
That's okay. Okay, let's continue our class. This is for data exchange instruction. S is a stack operation. We have already introduced stack is a special memory for saving some date. push is save saving pop is read or get the date get data. When this instruction is executed, the SP stock points add one, then the date is read to the address read to the stack read to the stack. When we read from the stack, the dates in the stack move to the address, and the stack points are -1 -1. Arithmetical instruction for assigned constant including the following 7 types: addition instruction, addition with carry bit, subtraction with carry bit, incremental, decremental, multiplication, division, decimal adjust instruction, is add instruction, add this one to this, add this one to this, then save the result to this one, you can see always an A, add, just like here, the 2 parts add and save the result to A, this instruction affect PSW register, as additional instruction with carry bit, ADDC, here is ADD, here is ADDC instruction, ADDC A, comma R6, A plus R6 plus CY, and get the result and save it to A, So with carry bit with CY, actually 3 parts to add, so ADDC, subtraction instruction, with carry bit, SUBB, A R6, which means A minus R6 minus CY, and get the result, save it to A, this instruction actually there are 3 parts, Incremental instruction, just add one, It's all incremental, add 1. Decremental, subtract 1, minus 1. multiplication and division instruction MULAB MULAB multiplication A and B the result no bit is saved to A. The high bit high batch is saved to B the A times B A times B times B. If the product is greater than 255 0 FFH then OV is equal to 1 OV equal to 1 DIV AB A division B divide B A divide B A dividend B divisor A quotient B remainder remainder. This is the result. This is the two part before division. Two part before division. Affect PSW. If CY is equal to 0, if divisor B is 0 0 then OV is equal to 1 or else OV is equal to 0.
What is this PSW?
PSW is a program status words. Program status words. Sometimes we execute some instruction. The PSW will be affected.
Okay. But Laushi, can you write these things in full format? Because after in time of revision, then maybe we will forget about it.
Program status word. That is in chapter 2.
Yeah. You
So
want to know
everything is
this
written there?
PSW?
Yeah.
You can see the chapter 2.
So everything is written there, right? Lava? Okay, I'll find it, Laushi, no problem. Okay, Laushi, go ahead.
Okay, I can show you. We have PSW, program state word. Seven. Decimal adjust instruction. DA. Affect PSW. PACCY. Only applied to decimal additional, not decimal subtraction. When we execute this decimal addition, we can use DAA to change the binary to the decimal to the decimal BCD code. Change the binary code to the BCD code. For example, this is A R 5, 6H, R5, 6, 7H, execute ADD A5. After that, we use DA. We can get the result. We can get the result. This is the result. This represent the carry. The carry. So we can get the 1, 2, 3. 1, 2, 3. For the decimal. For the decimal. This is decimal. We use DA, just change the result to the decimal. Okay. Use DA, change the binary to the decimal.
Okay, Losh.
Logical instruction. ANL. ORL, XRL. ANL is AND, ORL all operation. XRL exclusive OR. CLR, CPLR. CLR is clearance. CPL is complementary. Which sometimes we just means in words. Rotation beats instruction. Didn't be instruction. There's 5 types. 5 types for the logical instruction. ANL operation. A and RN. A and direct and operation. And operation. ORL operation means all operation. AORN. AORN. A or direct. Or direct. XOR. Exclusive OR. Exclusive ORs. A and RN. A and RN. This is an example. For the XRO, difference is equal to 1. If the sum is equal to 0, is the 0. For the XRL. CLR. Clearance set to 0. CPL just invert.
Lashi?
Okay.
Lashi, can you go back the previous slide? Here it's a 0.0101 exclusive OR gate, and then 1100 equal 1001. How it should be?
How to get this result?
Yeah.
Okay. You need to remember this rule. This rule. Different is equal to 1. This is 0. This is 1. This is different. So we get the 1. This is 1. This is 1. So this is the same. So we get the 0. Here is 0. This is 0. This is 0. So we can get the 0. This is 1. This is 0. Different. We get the 0.
Okay.
This is a simple rule. A simple rule.
Yes, Lashi.
This is a CLR clearance just set to 0. CPL invert the A invert the V rotation bits instruction rotation bits instruction RLA RLA row left we can remember this instruction row left and Rn A n plus 1 the R an to an plus 1 this row right row right a n plus 1 to an this is RLC we row the row left with C row left with C and an to an plus 1 and the a7 to cy to cy to a0 cy to 0 this is the rule this is rule you can see this is the rule you want to this rotation bit instruction you need to remember this rule this rule this is left rotation right rotation this is left rotation with with C with C okay this today we have introduced many
okay, we need to memorize this chart, the previous one, the previous slide. We need to memorize this serial, this series.
You want what?
This rotation bits instruction. So we have to memorize these things or not?
Write this.
What?
Sorry,
yeah, I asked. We need to know this serial or not? This a n plus 1 from an.
Oh, you if you want to use this instruction, you just know these rules how to use how to execute this instruction this is for the rules rules.
So in which field we need to use this formula or
which field?
Yeah.
Sometimes we you know in the decimal we move the digital to left which means we times 10 with times 10 yeah
in
the binary we move the binary to left which means we times 2 times 2
so
yeah so if we move to right which means we divided by 2 divided by 2
okay
yeah
but
okay so much for today so much for today
yeah,
we,
so much.
we can see you
it's
next
really,
week
it's really
okay
complex.
We have a suggestion.
what
We have a suggestion.
you see
is not easy when we study online because it's not easy to ask you questions. So is it possible that maybe sometimes we can meet in class?
You want to meeting at the class?
Yes.
Teacher, it's
Okay.
arranged by office, and Innocent, maybe you just talk with office first.
Bro, we've already spoken to the office. They said if
I'm
the teacher
talking to
agrees,
the teacher,
it's
please.
agreed.
No.
Can you let
This
the teacher
this
answer?
class is already arranged by teacher, not the office, not teachers. So you should talk with
Bro,
the
we've already
office
spoken to
first.
the office. They said if the teacher agrees, we can go
We are
to
just
class.
asking the teacher for us
They
who are
said
in
if the
class,
teacher agrees, we can
just
go
to
to
see
class.
him.
That's what Miss Peng said.
But we also ask this.
Just let the teacher answer.
So, teacher, what is it possible that you can join us in classroom, like some days?
If you want to have this class in the classroom, I need to contact the office.
Yes, we will really appreciate it.
Yeah,
Thanks.
please.
Shisha.
Okay, I will connect the officer. Tell them your question. Okay.
Yeah, it's very important for us because we don't understand, and take a call when burang yi.
I know. This class
Yes,
is
Lassie, we
difficult
really
for you to
appreciate you.
understand.
Yeah.
Us in the classroom, really.
Yeah, so Laoshi, thank you. We hope next class we can go in class. Thanks.
Yeah. Oh.
Class is over.
Before the office give our new arrangement, I need to continue our class. I need to continue our class. So maybe you think this is class is difficult for you to understand.
Yes.
But after we have some fundamental knowledge, we will give you some simulation. You can practice the simulation in the computer with your computer. Okay.
Yeah.
Before we have any fundamental knowledge, we cannot use this simulation software. So you need to wait after maybe several times. We can practice the microcontroller with the simulation software.
Yeah, Lassie.
You're right. Practice is better for us to just read the PPT.
Yes.
Yeah. Okay.
Okay, Lassie.
After we have some fundamental knowledge, we can practice.
Yes, Lassie, definitely.
When we practice, we can go back to the fundamental knowledge.
Yeah, you are right, Lassie.
Okay. Any questions?
No,
teacher.
Okay, so much for the day.
Last year. Yeah, I know we have the simulation application, but I want to see if I can buy a board. Which board do you think is okay to buy in China?
There is many boards. If you buy some board, maybe it's not for the request for our class. So I suggest that you needn't buy the board so annual. Maybe if you have some, you can make some simulation if you can make some simulation, you can buy some board.
Okay, then.
I think it's annual.
Okay.
Too annual
Thank
for
you.
you to buy some model.
Okay.
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 You need
Yes,
to
Laoshi.
hurry.
Okay. Noted.
Okay.
Yes, Lord.
Yes.
Okay. So much for the day.
Yes,
You,
Lord.
you are
Bye-bye.
dismissed.
Thank you.
Thank you.
Thank you, teacher.
Thank you, Laoshi. Thank you.
Thank you, everyone.